Hello, welcome back again, guys. I am Saurabh Suryawanshi here. Today, let's we do some practical of LED. In previous practical, we just turn and on and off the LED automatically, but today practical we actually on off the LED by switch. I hope my voice is audible. Let me check. There should be no problem to hear you. To hear you. Okay, there is no problem. Let's do the practical. In our in our left side, here is the program, and here is our connection diagram also. Let's build that diagram in Protus and also in Kill program. And after that, we upload the program and see the output in real time. Anyways, they start the program from kill. No, in first start from Protus. Just go to the maximum. New project. Give the file name le back led on off by switch space LPC2148. You can use simple name also, and path is important for us, so we can remember the everything correctly where is our program is saved. So after for in uh, for another kill program we need that path, and also another in flash magic tool we need the path. That is the reason I said this path so I can remember. After that you should click next by default, and then do not create next. And here actually you we don't need to create a firmware, um, but if you want to create you can create. If you don't want to use skill, then I suggest you can go and create. But for now, we don't need actually, because we are doing using kill. Just I don't want to use kill, but you can use the kill. I just want to show you how to create that firmware. Our family is ARM7. Then controller is not here. You can scroll down from here. PC2138 oblique 48, both are nearly similar. And then compiler, we have two compilers, GCC for ARM and kill. You should select kill, or I suggest you can select kill from R. And if you don't have that kill for ARM, go to the compilers, and you can see here this is for ARM, and you should click here download. It requires internet and it takes some 5 to 10 minutes, and after that you should manually install that. And after that they check all and then press OK. But as I told before, we don't need this for now. But if you don't have practical, then you don't need to create that. If you don't have hardware, then for now we have hardware, so we don't need to create firmware. Just press next and finish. This is our schematic, and actually we need firmware. Anyways, no problem. We can what is the benefit of firmware? We can get the ready-made circuit, but we don't need to worry about that. We need some pick the components, So how to pick the components? Go to the here component mode and then click here P icon. Then we need to search here first. Our controller is LPC2138. Just double click here, so it is added in our list as you can able to see. After that we need LED to show the status, and remember LED should be active so you can able to see in Proteus. Let's choose the blue one and LED is added. Then we need register for the switch. For pull up register means I show you later why we need this register to use as a pull up register, and then the register is added. And after that we need a switch. Just type here switch, you can get the switch here. Just double click here and switch is added, and then press OK. Now we have done. Just place the just click here LPC214 IC and just click here, it is added. Just click. For this IC we need some power supply. How to do the power supply? Just click, right click, place terminal power. We need power for reset and also for here VBAT as well as V3. After that we need to give the ground. Right click, place terminal ground. I have placed here, and this is the pin we want to use the ground. You double click here, give the name plus 3.3 V capital, then press OK. Now our circuit is ready for this only. After that we need to place our components remaining. Just click here component mode, and then you should place first LED. Just click here, the little bit zoom so you can able to see. This I want to place here. Let's place. Then we want to place register, and we let me see first. Okay, I have placed register here. Then switch, I have placing switch in that position, and we have done. Let's connect. We have connected LED here, port 0.0, and this pin is connected to the power supply. So I should provide power here, and power should be around plus 5 volt V capital, and then press OK. After that, as I told you before, this is our 0.1 is our switch input. You can connect switch like that also, it is possible. Just place ground. But what happen if switch is open, then this input pins is floating, is not either 0 or neither 1. So you should give some voltage there, or you should give their proper ground or proper voltage something. It should be not floating. Floating means is neither 0 and neither 1. Like this here, it is open, neither 0 neither 1. So that is the reason we use 10 kilo ohm resistor. The 10 kilo is important us because it is giving very less supply to this port, but not high or not 0. Is giving weak high signal to this 0.1 port, so it is good to have that. Let me connect here and then here, and this is connected to this. Now if I connect this pin to the 5 volt, then this resistor is called as pull up resistor because it is connected to the 5 volt. That is called pull up. Up is 5 volt. If I connect this wire to here, then this resistor is called as pull down because normally is giving low ground to this pin. So it's our choice which we want to use. So I want to use as a pull up resistor, so I have connected to the 5 volt, and this is our circuit is ready. And let's see the program. So we need to open kill. In that, go to the we need to create first project. So go to the project, new project, you the path. As I told you before, I knew the path. This is the path, and I giving the mm, file name like led with switch, then save. And this is the older version of the kill. That is the reason you're not able to see this before. But don't worry, this is the same. My controller is from NXP and the IC is LPC2148. Yes, this is our IC, and press OK. In your case, you can just type on search window or IC name and get the things. And after that, you should press here yes, and then you can get this thing. After that you need to create press here new file. After that you should press control yes, and here you should give the file name. I am giving the same file name with extension .c. .c is important here, and now you can save the program. And after that, go to the source group 1, right click here, add files to the source group 1, then you should select this file, then add, and then close. And now you can able to see this is our file, and you can type here program. I think I already copied the program. This is our program. Let me give some good look for that program, so it is easy. Now I can explain the program to you also. Before that, we should compile the program by clicking here build. We get 0 errors, and after that I explain the program. Let's see. We have to remove this 3 to 4 and then save again and then compile again. 0 errors. hash include. This is our IC name. Controller name is EPC214XX represent series of 4. This is header file we include. After that, we include here IO0 dir, and this is the 0. This is the file. This is the hex value which makes 0 port 0.0 as a output port, and port 0.1 bit as an input pin. After that, this is the switch case we use. If port pin is high, then only the output LED is on, and that LED is uh, pin is here 0.1. I show you. Here you can able to see. Here is our value is 0. We just I just want to show you. We have connected LED to the port 0.0. So I should remove this completely. We connected LED here. So the value for that code is 000 and 1. And then this is our hex value for that LED. Okay. So that is the reason this is the 1, and IO clear is clear the LED first. If pin is high, then LED is off, otherwise the LED is on. This is the reason IO 0. You can use here 1 also. This is a simple program. Set is used to use the high output for this port, and clear is used for removing is just use the ground signal to this port. That is a simple program. After that, you should compile. After that, go to the here target option, then output, then click here hex file. I have already given name, same name as a project, LED with switch, then press OK. After that, you should compile the program once again, then build program. As you can able to see, creating hex file, 0 errors, 0 warnings. After that, the main things is begin. This is the tool, Flash Magic tool we want to use for uploading program for our PC to our kit. Bef Before, if you don't have this Flash Magic uh, file program with you, you can get the program by clicking just I button here. After that, you can go to the you can download and install. After that, go to the options, advanced options. Then you should click here hardware configuration. In that tab, you should click the both the things on, and then press OK. After that, you should you should select the controller. Our controller is LPC2148, then press OK. After that, you should connect your board via USB cable or DB9 connector. If you are using DB9 connector, then by default the comport is 0. But in my case, I am using DB9 to USB converter because I am using laptop, and laptop doesn't have DB9 connector. So how to know where this port is? So for that, press Windows button, search device manager, then press OK, and here you can see the ports. In that port section you can able to see USB serial CH340, and after that this is the COM port. The COM port is 4. That is the reason I set here COM port 4. The baud rate I use here is 7200. Interface type is non ISP, and then oscillator megahertz is 12 megahertz. After that you should give the file, hex file. For that you should just click here browse button and just locate your hex file where that you save. I have saved here LED with switch. Then this is our hex file we created now. Then press open. After that, remember you should click here erase all code RD port and verify after programming is click. And after that, I want to show you actual demo. Let me connect my camera. This is the kit we are using for this practical. The kit is from ARM7 and from MIKBROS system. I want to give some introduction about the kit first, so you can able to handle the kit well. The first thing I want to show you, this is the on off switch. If the switch is pressed, then the kit is on, and if the switch is non pressed, then the kit is off. I am pressing the kit is on now, and I want to show you something. You can able to see here. This is the switch. Remember, you should you should turn off all the switch except from this switch. This switch is used for communication, for uploading program, and this switch auto PGM, it should be on, and other ports should be in off condition. This is the connector divided to USB, and I have connected here at the port, and you are port 0, and this is the port 1, and I have connected to the UR port 0. After that, you should take care everything is off switch, and after that you should just press here reset switch once again for 2 to 3 seconds. I am just pressing, and you can able to see that there is a LEDs. This LED is on while uploading the program. You can able to see here, this is the transmitter and receive LEDs. It should be on and off during uploading the program. Now let's upload the program. As you can able to see here, we just need here to press start button. I am clicking the start button, and you can able to see here programming, and the two LEDs are on and off here. And now our program is finished uploading. Now what we need to do, let I want to show you. Our LED is connected to the port 0.0, and switch is connected to the port 0.1. This is the IO ports here from 0.0 to 0.30, 31, and again this is the again port 1. So we just need to use 0.0 here and 0.1. For that we need some jumper wires, just two jumper wires, and I want to show you this is the LED section and this is the switch. If switch is pressed, then LED is on, you can see. But this is enable LED. We want to control these LEDs, and these LED are connected to these pins. So I just need to press. I need to give here input signal. So I am just putting jumper wire here, and after that our switch, our LED is connected to the port 0.0, means here 0.0. After that we need to give the switch input. Switch input is come from here, switch 1, switch 2. This is the interrupt, external interrupt, but we now it is turned off because we switch off that interrupt from here to go to the controller, but the output from this is come from these pins. So we are using this pin to get the switch input. So I am using here in external interrupt pin 1 as a switch. Remember, this input is not coming from these pins. We are getting from here jumper wires directly. We use as a switch here, and switch input is, as you can able to see in diagram, 0.1, and our is, this is the 0.1, and I have connected here. Now you can able to see uh, the LED is on, and that LED is connected to the port 0.1, as you can able to see here, but the LED on the board is not. This LED is connected to the port 0.1 from here, and you can able to see if I press the button here and then the LED is on. Let me show you. Okay, both LEDs on simultaneously, means our program is working completely fine. If I just turn off that two LEDs from here, I hope you understood our program well and then the practical. As you can able to see, the LED is on. Because the LED is on, that LED is connected to the our pin 0.1. That is the reason that LED is on. And that's it for this video. I hope you understood practical well with the simulation. And now let's see the simulation as well. I just want to turn off. This is our simulation. Now let's first we need to give hex file. So by just double click here and then program file. Then this is the our program file, hex file, LED with switch. Then press open and then click OK. After that you should click here run simulation. Now the LED is on. If I press here, the LED is off, that we saw earlier. I hope you understood and have a great day. Now the LED is on and now the LED is off, because you can able to see the ground is connected here and ground is represented by the blue. The LED is off and now the LED is on. Anyways, I hope you understood the practical, and don't forget to subscribe my channel and save the all files which we have created, and have a great day, and share my channel with your friends so I can reach to 1K soon. Have a great day.